Imperial Yeast is at it again with their Imperialis project, creating yet another unique proprietary strain through hybridization. In addition to its excellent attenuation and rapid reduction of diacetyl, I-10 Mangostini contributes robust ripe tropical fruit, strawberry, and lychee notes that complement modern hops. And as a Kveik hybrid, it can be fermented anywhere from 78 to 90 degrees Fahrenheit or 26 to 32 degrees Celsius without any negative issues. Head over to imperialyeast.com to learn more about I-10 Mangostini and be sure to pick some up for your next batch of fruity IPA. Welcome to the Brew Lab. Yeast do so much of the heavy lifting when it comes to making beer. Of course, they're making alcohol and CO2, but they're also making a variety of flavor components that can change depending on the conditions that they're in and access to nutrients, or if you're interested in harvesting and repitching them, genetic drift as they adapt to the harsh conditions of fermentation. I'm your host, Cade Job, and today I'm back in the lab with my co-host, Jordan Folks, as we apply the science from last week's episode, Changes in Yeast Proteins During Fermentation, with Dr. Riddiman Garga.
It's often said that brewers make wort and yeast makes beer. And if that's the case, we probably need to take good care of it and make sure that it's doing what it's supposed to be doing and it's not, picking up any contaminants or genetic drift or what have you. And it's really the most expensive ingredient per ounce in the brewery. And so it makes a lot of sense to try to reuse it.
Yeah, absolutely. I always think about that quote, and I think about every time that people refer to brewers as yeast janitors, and I'm just like, that's totally true, right? We're either like managing the yeast, we're basically just cleaning everything so that the yeast have whatever conditions they need to do what they need. But yeah, so Riddiman and I talked about his research, which was looking at how proteins change during fermentation and after cereal repitching over 14 generations, which was pretty cool. And so looking at those proteins, we can start to piece together how yeast is changing, both from a metabolism perspective, but also from a flavor perspective, because proteins lead to esters and higher alcohol and major contributors to flavor. So looking at how these proteins change give Jordan and I a great springboard to talk about yeast management. So things you could consider when maintaining your own yeast library and how to give your yeast the best conditions to survive. So this should be a fun episode, and hopefully we're able to build off of what Riddiman talked about in the last episode. But first, if you're not already a patron of Brülosophy, please consider becoming one. We really appreciate the support we get from our patrons, and as a reward for your support, you get access to unpublished contributor recipes, discounts at YakimaValleyHops.com, and an invite to a monthly live Q&A session. Becoming a patron is easy. There's no obligation. You can cancel at any time. But if you're out there listening to this show, I really hope you'll check it out. And this month's guest is Dana Garvis of Oregon Brew Labs. If you have questions about how to get your beer analyzed or want to know more about the different analyses that you could have on your beer, or just have questions about what's going on during fermentation, Dana's a great resource. To make sure you can attend this session, you need to become a patron, and you can do that by visiting patreon.com/Brülosophy. Another great way to support us is by using the links at brülosophy.com/support. There's some really cool affiliates who give us a small kickback if you purchase from their site by using one of Brülosophy's links. It doesn't change any part of your shopping experience, but it does help us out. Head on over to brülosophy.com/support to check it out. This week's feedback is brought to you by the folks from John I. Haas, who over the last couple of years have released a handful of really cool products like Lupamax, Incognito, and Flex, all intended to improve beer while reducing vegetal matter and thus increasing yields. Well, they're excited to announce the latest 100% hop-derived product made especially for your patio, lawnmower, and beach beers. Kettle Ready imparts smooth, light, stable bitterness and kettle hop aroma to beer while offering microbiological protection during the brewing process. This new product is easy to use and has no special dosing requirements. Plus, due to its standardized high alpha acid concentration and a light, stable molecule, it gives the light stability and bitterness characteristics desired for all traditional beers. And it plays well with other Haas products, including Tetra Hop Gold, Hexa Hop Gold, and Ready Hop. For flexibility and optionality when brewing light, stable beers, learn more about Kettle Ready at johnihaas.com. That's John, the letter I, HAAS.com. All right, this week's feedback comes from listener Paul about oxygen levels when capturing CO2 during fermentation. And he says, Cade, first off, thanks for all the content. Just listened to the Applying the Science episode yesterday, and I'm wondering how my math stacks up with everyone else who listened and thought they had to calculate residual oxygen when purging a Starsen keg filled with CO2 generated from fermenting. I did the math for my system, which is a Spike Flex fermenter and standard 5-gallon corny keg. If you hook up from the get-go, you get 12 ppm ppm of O2. If you let it ferment for most of its run to clear out the headspace, then hook up to purge the keg, you're sub ppb levels. Anyway, keep the good stuff coming. I enjoy hearing you and Jordan's technique and tricks. Thanks again. Paul also laid out his calculations. If anyone's interested, I can send them to you. But the long and short of that is, like he said, if you connect your keg and let the CO2 generated from fermentation purge the keg, you might actually get to sub ppb levels in the keg when you're ready to pressure transfer.
I mean, I was curious what you thought of the math, because I looked at it and I got pretty lost pretty quickly. But assuming the math checks out, this is awesome news.
Yeah, for sure. I mean, I think the math checks out. It also, I'm to be clear, Paul's math was over my head as well, but it looks like it checks out. And from a I don't know, what do we call it? From a gut check standpoint, like what does my gut say about this? That actually makes a lot of sense. A ton of CO2 is produced during fermentation. I mean, it's like a crazy amount of CO2 that's produced. And so, yeah, if you're using that to purge out the keg that you've got, let's say, filled with Star Sand with a little bit of headspace on the top, wherever the foam is at the top, right? You purge that out, purge that into another keg, and then that keg is just filled with CO2. And it's true, if there was oxygen in that keg, you can never fully get rid of the oxygen. You're just going to reduce it, right? But if we're down below ppb levels and his math is accurate, then yeah, that makes a lot of sense. All that CO2 is just pumping in there. So it starts with just a little tiny bit of air in the headspace and whatever oxygen was in the Star Sand, and then that's just being flushed the whole time. You're just pushing more and more and more CO2 into that keg. And so, yeah, it makes sense that maybe we are getting the oxygen down to that level. Makes sense to me, at least, Jordan.
Yeah, I love it. And I think it really fits into this episode, which is about, saving some ingredients and saving some coin by reusing these raw ingredients that may have more than one life in them.
Yeah, exactly. And again, if we can reuse some of that CO2, that cuts down on the amount of CO2 that you've got to keep on tap. So yeah, this is another great sustainability metric. We talked a little bit about yeast management and repitching and harvesting last week when we talked about sustainability, but we're going to go into a lot more detail, which we'll do right after this short break. One of the biggest improvements to my brewing practices was the upgrade to stainless steel, and Delta Brewing Systems offers some of the lowest prices on high-quality stainless gear, like the Firm Tank, which holds 8 gallons or 30 liters of wort, comes with a domed lid to reduce the chances of a messy blow-off, and it can hold up to 4 psi of pressure. Delta Brewing Systems also has their own line of brew kettles, as well as one of the lowest-priced all-in-one electric brew systems out there, and their prices are remarkably affordable. If you're in the market for legit stainless gear that won't break the bank, you've got to check out deltabrewingsystems.com. We all know that designing recipes is really fun, and doing it well is so much easier with good software. We at Brülosophy recently made the switch to Brewfather, and honestly, y'all, we could not be happier. Brewfather utilizes the latest technology to bring you the most robust cloud-based recipe design software that can be accessed anywhere, on your phone, tablet, desktop, and even offline. It also works seamlessly with numerous third-party devices to make it easier to monitor every step of your brew. I know change can be difficult, but trust me when I say you need to go to brewfather.app today to try it out for yourself. That's brewfather.app. Taking care of your yeast or providing the right conditions for fermentation, ensuring access to nutrients, and knowing when you've pushed things too far are some of the most important skills that brewers can learn. So, Jordan, how much time do you spend thinking about yeast management?
Actually, I think about it quite a bit because I'm brewing fairly frequently, a couple times a month, and I'm using different yeast strains, and I'm kind of like a brewer of convenience of sorts, in the sense of I'll kind of look at what I have at the house, look at my hops, look at my malt, and look at my yeast, and figure out what style seems to be emerging from the levers that I have in front of me to pull from. And yeast is a big part of that. So I'm thinking about cell count, yeast health and viability, and trying to make sure I have enough. And if not, then what? Do I need to build a starter? Do I choose a different style? Do I go get some more yeast from the store? So I definitely consider yeast quite a bit in my day-to-day brewing thinking.
Yeah, for sure. I mean, and that's a good point too, right? Like recipe design. If I don't have that yeast on hand, if I don't have a lager yeast on hand, I'm probably not going to brew a lager, right? I mean, I could try it maybe with Chico, but I don't know. I mean, there's just something about that crisp, clean fermentation character from a lager that I really like, and I don't know that you can, substitute like an ale yeast for a lager yeast when you're looking for certain characteristics and styles. I mean, I think there's ways to ferment at different temperatures, and you can probably get a clean ale character from it. But man, yeah, if I'm trying to brew like a German Pils and I don't have any German lager yeast, I don't know what I'm going to do. But that's one thing that's really interesting about yeast management, right? I mean, why do we even talk about yeast management at all? And that's because yeast is doing the hard work in the beer, right? It's the thing that we pitch into. We make the sugar solution, like you said, Jordan. We make wort and yeast makes beer. We make the sugar solution and the yeast does everything else. It does all the fermentation. It does all the flavor generation. Well, not all the flavor generation, but a huge majority of the flavor generation. And that's something that I notice a lot is if you brewed the same batch of wort but pitched two different yeast, it's going to taste wildly different. If you brewed the same batch of wort or the same specifications but used pale ale versus Pils malt, I don't know that it's going to taste all that different. If you brewed a batch of beer to the same specifications and used Citra and not El Dorado, I don't know that it's going to taste wildly different. It depends, of course, on the amounts that you use. But if you brew a beer and you use Chico yeast and then use juice, that's going to be different, right? Flagship and juice are going to produce a different beer.
And, maybe even 1056 and USO5 versus 001 versus Flagship. These are all purportedly the same yeast, but as I think you've even covered in maybe prior episodes, there may be some genetic differences even from strains that are allegedly interchangeable.
Yeah, totally, right? I mean, and that's interesting, right? We bring up this genetic difference between those different strains, and there has been some proof out there, right? That a couple of companies have gone out and picked up 001, White Labs 001, and Y Yeast 1056 and Flagship, and I can't remember the one that it is for Omega Yeast, but picked these up, and they're actually potentially genetically different. Right? They're genetically different yeasts. And I wonder how much of that is because of genetic drift. And of course, that was the topic that I talked about with Ritteman last week. Now, Ritteman studies with, he was at the University of Texas at Austin finishing up his PhD research, and now he's up in Seattle at the University of Washington studying with Maitreya Dunneman. Maitreya, of course, has done a lot of research on how long you can repitch yeast cells and what genetic drift actually happens. So I'm excited to have her on, in the coming months to talk about that specific issue. But Ritteman was looking at proteins. And so it's kind of like, okay, if we assume for a minute that the yeast genome changes, what is the actual output, right? So like, how is the beer changing, right? And that was the focus of Ritteman's research, and I thought that was really cool. So of course, the first place that we started, and the place I think that you and I have to start too, Jordan, is the biggest thing about yeast management is that wort is a hostile environment for yeast. All right, we got to understand that as brewers, so that's a tough place for any organism to survive. Now, yeast can survive, but it's tough in there. Right,
and if you're looking at like a kettle sour, it's even tougher. So there's a high OG, right? Also tougher. So it's inherently hostile, but then there's some things that make a bad situation worse.
Yeah, like exactly. Like if you're not paying attention to what the yeast needs. So of course, what we're talking about there, and like you mentioned with a high OG batch, it's just that there's so much sugar, right? So much sugar, it creates these osmotic stresses. And I think Ritteman and I talked about an analogy. It's kind of like jumping in a swimming pool, right? You jump in a swimming pool and your skin gets all pruny and it changes, right? Because there's osmotic pressure. That's the water that's outside of your body trying to get in your body, and your skin is the barrier. Yeast has the same thing, right? And in the presence of a whole lot of sugar, that sugar would try to get inside of the body. And a good way to think about this too is, have you ever seen those like candied sugar like fruits, like candied lemon peel or candied orange? Do you know how that's done, Jordan?
No.
Yeah, it's actually just an orange or a lemon or whatever, or a lime that's either sliced or cut in half, and it's just put in a whole bunch of sugar. Like just straight table sugar. You just put it in there, you leave it out on the counter for like a couple weeks, and that sugar pulls out all of the moisture out of the lime or lemon peel or whatever, lime, lemon, citrus, whatever you're doing there. And it makes it essentially candied. It dehydrates it. It pulls all the water out of that solution, and a little bit of sugar goes in, and it makes it taste like sweet and citrusy. So like imagine you're putting yeast in this situation where there's all this sugar floating around it, and that's sort of what's going to happen. The yeast has got to figure out what to do. It doesn't want to turn into a shriveled, candied lime peel. It needs to do something with that yeast. So it's got some evolutionary adaptations over the years that have made it excel in wort especially. It can take maltose and break it into 2-glucose, and then it can use that glucose to rapidly generate energy and use that energy then to grow and make a whole lot of other cells and live its happy life. But it's tough in there, and it needs things to survive. So that cell wall is super important. Oxygen and nutrition are the highest, are the most important ones. So do you oxygenate your wort, Jordan, whenever you pitch, or what are you doing there to make sure you have enough oxygen in the beer?
I do. I use pure oxygen, and for ales, for 5-gallon batches, I'll do 1 minute, and then lagers, I'll do 2 minutes. I don't do a ton of like super crazy high OG beers, like 35 Plato beers or anything like that. But if I would probably follow up the next day, like the next morning or something, with an additional couple minutes of pure oxygen. There a notable exception is I do not use pure oxygen in my Hefeweizens when using a German Hefeweizen strain. That's one trick I've heard, is that you want to really stress that. So pitch really low pitch rate and no oxygenation. So I've not experimented really in a side-by-side triangle scenario of no pure oxygen versus using some. But I've always really, since pretty much the beginning, used pure oxygen. I've been having really healthy fermentations. But as you know, first generation pitches may not need it as much as subsequent generations.
Yeah, exactly. This is where it becomes a big deal whenever you when you repitch. And this was the thing that that Lance Shaner was talking to me about whenever we did the episode on olive oil. We were talking about, can you substitute olive oil for oxygen? And the answer to that is no. Olive oil is not a substitute for oxygen. It may be a substitute for UFAs, unsaturated fatty acids. There we go. It might be a substitute for those, but it's not a substitute for oxygen, because oxygen is used to make ergosterol, and ergosterol is one of those key things that regulates that cell membrane. So that's just kind of thinking that in the back of your head. Now, if you were actually able to totally like aseptically and without exposing it to air at all transfer yeast from batch to batch, you would eventually run out of ergosterol, and the yeast couldn't survive in those osmotic conditions. Adding oxygen, or at least exposing the yeast to oxygen during repitch, is a super critical nutrient for yeast whenever you're repitching it. So yeah, I mean, Brülosophy's done some experiments using fresh pitches and oxygenation, and there wasn't a significant difference, right? When using a fresh pitch. And so yeah, that's where I would go, just like you said. Fresh pitch, you probably don't need oxygen, but if you are harvesting and repitching, that's something you really need to consider, especially if you're getting off flavors, or you're getting weird like higher alcohols or esters that you didn't have before.
Yeah, and so kind of breaking it down numerically, if my memory serves me well, you're looking for about 8 to 10 ppb of dissolved oxygen in your wort. And I think the big thing there is this is especially important if your yeast is lacking the sterol, right? And so that's going to happen with subsequent repitches. And so that rule of 8 to 10 maybe isn't as necessary if you have super vital, viable, fresh yeast. They still have those sterols, and they're ready to do the job without this additional ppb. But they've kind of run the numbers, and it's just not physically possible to saturate that much oxygen into your wort by shaking a carboy. It's something like there's not enough ppb in the atmosphere for that to ever like hit that types of levels. So if you want to hit 8 to 10, you've got to use pure oxygen. And so that is something that I'm actually interested in testing. Is apparently German brewers do not use pure oxygen because it's technically against the Reinheitsgebot. And so they pump sterile air into their lager wort. And there are a few lager nerd breweries, like I think maybe Goldfinger in Chicago area, forgive me if it wasn't them, but I've definitely heard of some German, well, maybe it was Dovetail, uses pure sterile air because they want to recreate what the Germans are doing. And there's this theory that is part of the X factor for making good German lager is the amount of oxygen that you can get via sterile air. In theory, we're getting too much to recreate classic German lager styles when just using a red canister of pure oxygen.
Yeah, exactly. And I'll tell you, that's what we do at Oregon State in our research beers. We use sterile air. We don't use pure oxygen whenever we're oxygenating. Yeah. So, I mean, it's really interesting that you can do that you can use sterile air instead of oxygen. But again, that's all about providing the yeast, the nutrients that it needs. And of course, there are other nutrients, and you can actually add a product called yeast nutrient, right? That's going to give you, dead yeast cells, which are going to have a lot of zinc and other ions that are cofactors for different metabolic pathways in yeast. I'm not going to go down that path, but essentially it's just more nutrition for the yeast. So these things are great to give you, to help your yeast along. And especially if you're repitching and harvesting yeast cells, you need to think about nutrition. You need to think about yeast nutrients and oxygen. But you also said two terms there, Jordan, that I think are also super important and often sometimes confused. That's viability and vitality. Right? Those are also important to know.
Right. So viability is effectively the count of living cells in a solution, right? And so one way to think about that is if a pack of imperial yeast for homebrewers starts with 200 billion cells, over time, some of those cells will die. And so there are viability calculators to tell you how many cells are left. And at a certain point, it's predicted to be zero. But that being said, Brülosophy contributor Will Lovell was just texting us in the group thread today, I think, that he pitched 2 packets of 2022 expiration date Bella Saison, and it kicked off the next day. So
that's amazing.
and actually, that's a good point. Is that a lot of the things we're going to talk about today, there are different considerations as it relates to dry yeast versus liquid yeast. And so in theory, a dry yeast has a much better shelf life because its ability to maintain viability over time in that, vac sealed, dehydrated package. And so viability is definitely something that brewers want to be paying attention to because all yeast is not created equal in the sense of it's not all created on the same day. And so you want to be mining that and making sure that you're pitching viable yeast because if it's too old, you might not see fermentation occur.
Yeah, exactly. I mean, viability is super important. It's also one of the things that brewers can actually calculate too, right? If you've got access to a microscope and you've got some blue stain, methylene blue stain, you can calculate the number of living cells that are present in your solution, right? So if you've got a fresh pitch of yeast and you're just curious, or you've been harvesting and you've got a jar of slurry and you don't know how much yeast cells are in there, you can actually calculate that and measure it using a microscope. You can visually do it. All brewers can do it. There's an ASBC method out there. I can help you with that. If you need to, just email me and I can tell you how to do it. But again, like you mentioned, there are calculators out there, and those calculators are shortcuts and they can help in that way. What's more difficult is vitality, and vitality is how healthy the yeast are. How ready are they for fermentation? So I talked a lot about this with Maria Mutzoglu from Coors when we talked about that low carbon, high nitrogen starter. So pitching at like 1008 OG and not the standard like 1040 OG for a starter. And you can kick yeast into respiration. And so they become a little bit more healthy. They have a little bit more energy reserves and maybe get started in fermentation faster. That one's a lot harder to figure out. So you may have a situation where you've got 200 billion living cells, but they're like sickly and dying, and that's no good. And really, there's not a good way that you can confirm that, at least from a brewer, without pitching it into some wort and trying it. So all of what we talk about today is how to make sure that those conditions that you don't end up with that you do end up with viable and vital yeast. So you end up with the right number of yeast and you end up with healthy yeast that you can pitch into beer.
Right. And so like we said with viability, you can use a microscope in the method to kind of confirm a more accurate estimated viability, because there's some sampling involved there, and you might be plus or off a couple percentage points, but it's gonna be pretty good. Or you could use a calculator, and those are flawed because different yeast strains have different levels of kind of viability within them, I guess. Like some are going to fade more quickly than others. Also the storage conditions. If you're sitting in water versus wort versus under pressure versus at room temp versus, frozen, all of these things are going to affect viability. And so the calculator is kind of like a middle of the road guess, but it's something. Vitality is much harder. And there's, as I understand it, there's not really a way for even maybe laboratories to like quantify vitality. But a tip is that if your yeast is kind of old, but you think you have enough cells in terms of like the viability cell count, either, observed or estimated, you can do a quick little day of starter. So once your beer has hit the boil, pull like 400 milliliters or something like that, and pitch your yeast in it and spin it during the brew day. Of course, cool it down, and spin it during the brew day. And then it's not enough to actually regenerate new cells and increase your viability, but it can wake it up. And that could be a really good trick if you think you have enough viable cells, but you're concerned about the vitality.
Yeah, I was going to say, like, the pre-fermentation is a good way to do it. There is a actual method for testing vitality, but it's way more advanced than most breweries are going to have access to. I mean, I'm talking like you're going to need like a full lab in order to do the vitality test. So it's really just not practical in a lot of ways. But that fast fermentation, that's the method. And I would say before you even get to brew day, like try to pitch what you would consider viable amount of yeast cells into a small fermentation, and it can just be regular DME or dry malt extract in a flask, and just spin it and let it go and make sure that it actually ferments all the way to what you expect for completion, right? So if you're starting at 1040 and you don't make it down past 1010, that's a problem, right? You need to be down below at least 1010 or your yeast isn't going to have fermented all the way. And so that's a good way to tell if your yeast is vital, by pitching the right number of cells, or at least what you estimate the number of cells is, and getting down where you need to go. Now, one of the questions I always have about like yeast management is how many yeast strains do you keep around at any one time? Because we can talk about like setting up the conditions for yeast, but you still have to like use that yeast, right? And you got to be brewing beer enough that these yeast aren't dying off while they're waiting in the refrigerator, right?
Yeah, and so I kind of treat my basement a bit like a mini, nano brewery of sorts, and I will kind of rock a given strain for several generations. And so kind of keeping a house ale strain, maybe a house lager strain, and then a house Belgian strain. Obviously, mixed culture is a totally different issue, and I do have various jars of mixed culture, Brett, Zach, Pito, etc. But we'll just leave that for another day. And so talking specifically about clean strains, lately I've actually been fermenting everything with Imperial's Pilgrimage. Be it a ale or a lager. I find that strain works really well for ale type beers at like 60 degrees Fahrenheit, and works really well for lagers from anywhere from like 45 to 54 Fahrenheit or something like that. So that makes my life even more streamlined. So then any specialty beer, be it like the occasional Saison or the occasional Czech Pilsner or something like that, then I've got to go acquire a new strain. And if I'm not brewing those a ton, I'll go ahead and after the fermentation, keep a jar, and maybe I'll get to brew with it before it gets too old, or maybe I'll give it away when it's starting to get kind of close, or maybe I'll make a starter. And by the time I finally getting around to brewing another Czech beer, it's reasonably viable enough to kind of start back over with a starter and not have to go buy another pack.
Yeah, I mean this is a really good point too, because it's like, as homebrewers, you have a lot of access to all of these different strains, right? Like you were saying, like if I want to brew a Czech beer, I can go and get the Czech or the Pilsner Urquell yeast and brew a Czech Pils with it. The challenge is when you make a transition like from home brewer to pro brewer, or if you're a pro brewer, you can't maintain all of these different strains, right? Because you've got a pale ale and an IPA and if you're brewing a lager or 2 different lagers, and then you're brewing a Belgian beer, that's potentially 5 different yeast strains that you now have to have a record of and know where they are and what condition they're in and when you pitched with it last and where it's going and how many generations, and all this becomes a nightmare and a headache. So for a lot of brewers, they'll have just 1 or 2 yeast strains, and they'll ferment all of their beers on those 2 yeast strains. And now occasionally they'll do their seasonal with a one-off special, like Belgian style yeast or something like that. But it becomes a really big problem when you've got a whole bunch of yeast around. Now, I honestly never got into harvesting and repitching yeast all that much. So I was always just kind of a fan of pitching from fresh pouches. So like the Imperial yeast, or, back whenever I was using, White Labs or any of the other, Omega, any of the other yeast brands, if you find a yeast you like, you keep it around and use it. And as a home brewer, it's kind of nice because you can just go down to the homebrew store and pick up the yeast that you want, or you can order it online and keep it around. But I wanted to ask you this question too, Jordan, is like, what are the reasons why you might want to harvest and repitch yeast? Like if you're going to have just like an ale yeast and a lager yeast, it'd be pretty easy to just go buy 4 or 5 packs of ale yeast and 4 or 5 packs of lager yeast and just pitch that every time. Why harvest and repitch?
A few reasons. One is I'm kind of lazy, and it's a lot easier to have your ingredients on hand than to constantly go to the store, right? And so there's obviously some cost savings associated with that, and that's appreciated. But once you get a mill at your house, you're very reluctant to leave your house on brew day to go acquire ingredients, right? Yeah. And so it's really nice to it's there, it's in the fridge, I'm ready to go, and it doesn't require constant trips to the store, right? And so I appreciate that, but I'm a big believer in proper pitch rates. And a fermentation can effectively double, triple, quadruple the yeast cells present, right? And so it's challenging to pitch a proper lager pitch rate with store-bought yeast. With viability losses accounted for, it could easily be 4 Imperial packs to meet the 1.5 pitch rate that I might be shooting for. And so that is another big thing, is that I'm able to generate more yeast, and it keeps the train going a little easier, and it's way more cost effective.
Yeah. And especially if you're brewing frequently, right? If you're brewing like once a week or once every 2 weeks, that's pretty, and brewing similar styles, right? If you're brewing a pale ale back to back, or, an IPA and then a pale ale that can use a similar style of yeast, it makes a lot of sense. Like you said, like you've got your ingredients that are readily available, and that cost savings is no small joke. A pack of Imperial yeast is like $8 or $9, for a home brewer. And for commercial brewers, it can be more expensive. And so if you can reuse that yeast, it's nice, and that nice to have that cost savings, and like you said, nice to have that strain that's available in your refrigerator. And there's also, I know one of the things that you've talked to me about before, Jordan, is that Belgian yeast strain that you used for your gold medal winning Belgian Pale Ale, right? That was a hard to find strain.
Right. Well, it was a internet only availability. It was from Bootleg Biology, and my homebrew store is well stocked on several brands, but they don't carry Bootleg Biology, right? And that at the time was a seasonal release that, after the sale goes away, they might not ever bring it back. And so for rarer strains, there's a real reason to keep them for that reason. For example, I really like Imperial's Rustic for making saisons. And in fact, I had an article post recently where I used that strain. I'm repitching it because unfortunately there wasn't enough demand for them to continue to sell to homebrewers. So I'm holding on to this thing, like a holy grail, because there's no other way to acquire it other than going to some other brand that may have a similar strain. Because I love Rustic, and I'm going to push it as far as I can because I can't buy it in the store anymore.
Yeah, for sure. Those hard to acquire strains are really important too. And I think of like sometimes strains from bottle dregs, right? People are into harvesting, strains from bottle dregs from some of those bottle conditioned beers, especially Belgian bottle conditioned beers that make their way over here to the United States. You really like that strain, but you can't find it, or you don't know which one it is at the store, right? Because it's not like Imperial is posting that, this is the, Belle Saison strain, or, this is, that strain that you can get anywhere else. They all have their own unique names and monikers. And so it's hard to know. So yeah, harvesting from bottles, the Belgian strain that you had, and now rustic, you never know when people are going to stop making these strains. Those are all reasons that you might want to harvest and repitch your yeast. But then to Jordan's concern, you also know, like, how many times are you going to be able to repitch that yeast, right? How long is Jordan going to be able to use rustic, before it goes bad? And one of the ways it goes bad is from contamination or from mishandling. So let's skip contamination and talk about that in the next segment. But for now, mishandling. So how do you store these in a way that makes sure that how and where do you store them to make sure that they're not going bad or the viability isn't decreasing so much that you just have a whole bunch of or very few cells or non-vital, non-healthy cells?
Right. So I store them in jars, just standard mason jars. I store them in the beer that they previously fermented. I'm not washing them or rinsing them or anything like that. And I put a lid on them, like a mason jar lid. And they will often create pressure due to tiny amounts of residual fermentation that are occurring perhaps in a refrigerated environment. And so sometimes it's actually difficult to open them because so much pressure is built up. Never had one explode. So you wouldn't want to do this if your beer was half done fermenting. Like, this is following attenuation before dry hopping, right? I wouldn't collect yeast I would dry hop after, collecting the yeast, or if I use incognito in the dip hop, I'm not going to recollect that yeast, even though I did do it once and it worked out okay. I just had to pour off the incognito oil that had collected in the yeast jar. But they say that you don't want to store yeast under pressure. And I'm doing that successfully, and I'm having good, healthy fermentation. So at the homebrew scale, it's yet to burn me so far. I write the strain number or the strain name, the harvest date, and the generation. And when going to brew a beer, I will then look at my yeast available or the one I'm trying to use, and then so I look at the date, right? And then I actually go into the calculator online and then use that date to discount the predicted viability. So in the next segment, I'll talk about how I'm estimating the cell count based on volume in the container. But let's say at 100% viability, I'm estimating it to be 400 billion cells, and my jar date is 60 days ago. I put that into the online yeast cell calculator, and it will give me a discounted viability rate. And at that point, maybe it's 40% viable. And it will then tell me, you have 40% of 400 billion cells left. And so then I know my starting point. And at this point, I'm pretty comfortable pitching old yeast as long as I have sufficient cell count. If it's super old, a vat of yeast cells that are predicted to only be 100 billion, I'd probably do a vitality starter or something like that, or maybe a proper starter the day before to rebuild up the cell count. But yeah, it's really simple, and obviously just being clean the whole time.
Yeah, so I've got a couple of questions about that. One is you mentioned that you're storing them, kind of under pressure, and that's one of the things that I've heard is really good. A good way to store yeast is storing them under CO2, right? So that they're not exposed to oxygen or they're not getting other air in those jars, right? Storing them under CO2 so that they stay nice and asleep, I guess, or hibernating. So that's interesting. Pressure, the pressure thing, I've definitely heard that before too. You don't want to store them under pressure, but you do want kind of under CO2 so that they're not exposed to oxygen or exposed to other nutrients that might sort of wake them up and get them active and fermenting. But then another question I had for you is, so okay, you've got these jars, in your refrigerator. One is, how cold is your refrigerator? Are you freezing any of these? Or are you just keeping them refrigeration temperatures? And then how long do they stay in there? If it's past X number of months, you throw it out, or is it just kind of how much yeast was in there originally and how much does the vitality or viability calculator tell me is left?
Yeah, I remember back in the day on, I think, Jamil and John's podcast, their recommendation was if it's more than a couple weeks old, just throw it out. And I found that you can go a lot longer than that as long as you're doing things proper on the front end. So I'm guessing that somewhere around the 3-month mark, there's not much left. That could be obviously confirmed with checking a viability calculator. But yeah, so anything longer than 3 months, it's, you just have to dump it down the drain. And what was your other question?
Yeah, like how long between uses? Like so if you're letting it go, 3 months or so, I guess that's kind of an answer, right? As long as it's not like a zero viable cells, you're still able to use a vitality starter, grow it back up, and use that yeast.
Right. I mean, and if it says like there are 10 billion cells alive when you had 1,000 billion cells, a few months ago, it's like, this is so much yeast mass. It's just, it's done. But as long as I'm at least 100 billion cells or so, I'm comfortable doing a small starter at the batch sizes that we're talking about, the homebrew scale. Your other question was temperature. And I keep it at, I don't actually know for sure because I have a little college dorm fridge that I use to hold my yeast and incognito and some things that are refrigeration temperature, and close to 35 Fahrenheit or so, I'm guessing. Cold enough to be cold, but definitely not trying to freeze anything.
Yeah, definitely not trying to freeze it. And you can freeze yeast. You can do it. You're going to have to go through a slow dethaw and all that stuff, or a slow thaw. I'm apparently one of the only people in the world that actually says dethaw. But you go through a slow thaw, and there's some other considerations that you need to be aware of there, because you don't want to rupture the yeast or heat them up too quickly whenever you're thawing them. But you can freeze yeast and keep them for long-term storage. I mean, that's in fact what most of the yeast banks like UC Davis has and Weinsteffen has over in Germany. The yeast banks that have hundreds of years of yeast that have been stored in their catalog. Those are super deep, super cold, super deep freezes, like really, really cold. But the point in bringing that all up is you don't need that. You keep them at refrigeration temperatures for a short period of time. If you're going to keep them for longer than 3 to 6 months, maybe consider freezing them. You can actually freeze yeast and then bring it back that way. But that's kind of outside of the scope of what we're going to talk about today. But again, the other main thing that you need to be aware of is cross-contamination, right? We want to make sure that when we're harvesting that yeast and we're maintaining it, we're giving it the things that it needs, that it is the yeast that we're intend for it to be, right? If you've got other yeast that gets mixed in there, or you've got a contamination or some sort of infection, or you weren't good in your harvesting practices, whatever you do to keep that yeast is going to be not worth it, because you're going to have mixed the yeast and created something else. And on that note, that's where I want to sort of enter into the next segment. How do you actually harvest the yeast? How do you make sure that it is not contaminated? And how do you make sure you've set it up for the long term? And then how do you reuse it? Once you're ready to pull that yeast out of the refrigerator, how do you pitch it in? So let's take a quick break, and we'll come back talking about how to actually harvest and then repitch the yeast.
Established in 1995, More Beer has been consistently serving the greater brewing community since the times IPA was expected to be bitter and clear, and there are reasons they've stuck around so long. In addition to their massive product selection and excellent customer service, More Beer has locations on both the west and the east coast of the United States, which translates into fast shipping times regardless of where you live. And when you spend more than $59, shipping is free. When you're in need of brewing ingredients and gear, there's no better option than morebeer.com, one of the most trusted shops on the planet.
From a cost savings perspective, harvesting and reusing yeast can save you lots of money. Yeast certainly isn't the most expensive ingredient in beer, but it may be the most expensive ingredient by weight of what you're actually putting into the beer, and it's relatively easy to harvest and repitch. So it makes sense for a lot of brewers. And Jordan, you've got experience in harvesting and reusing yeast, so let's talk about how to harvest the yeast to make sure that it actually that you can reuse it.
Sure. And, I love proselytizing the benefits of fermenting in a keg.
Yeah.
And this is the one downside in fermenting in a keg, is getting the yeast out is a little trickier. I just did it a few minutes before we did this podcast episode today. And with fermenting in a keg, you open the top, right? And you got to pour it out. And it's kind of difficult because you're not trying to contaminate it, and you don't want it to fall on the gas the gas in post on the way into your jar. So I will caveat that is the one downside with fermenting with kegs. But you got to get the yeast out of your fermenter, right? So if you're using a conical, you can perhaps shoot it out the bottom. If you're using a carboy, it's super easy. Once you've racked out, leave a little bit of remnant wort in there, and then swirl it around, and then have your sanitized jar ready, and you just turn it upside down and collect it that way. I've heard of people pushing it out with CO2 and using like a party tap or something like that to fill a jar, and that certainly could work, but you're going to need a proper dilution rate, right? Like if it's too thick, you're not going to be able to party tap it out very well. I go back and forth as to like what's the lesser of two evils, because how clean is that party tap? And so I've not been comfortable transferring yeast out via a line, because I don't want to pick up a contamination that way. So I just pour it by hand. But that's pretty much the gist of it, is have enough remnant fermented beer in your fermenter that you can swirl it all together and then get it into a clean and sanitized jar.
Yeah. And so one big thing there for me then for us to talk about too is one of the things that you're not doing that I hear people do, like say, oh, you have to do this if you're going to harvest yeast, is washing your yeast, right? Like that's a big thing that you're not doing. And tell us why.
Yeah. So washing and rinsing was a big to-do like 15 years ago in the homebrewing world, and it seems to kind of faded away. And I think it's one of the things that's kind of like a secondary, that it turns out that it might be doing more harm than it is good. So to kind of set the stage here, washing, as I understand it, is when you're using some sort of acid to wash the yeast clean, as it were. Rinsing is when you use water. And so what I've always heard is the best environment for yeast is beer. And so, the beer is hopefully pure and you just had this perfect fermentation and it's not infected. And so, the pH is right. And that it's not going to be a source of contamination. Water could be. And so probably the best practice would be to boil it first and then cool it down. And at the end of the day, it's just an annoying extra step. And I've only been burned once, and we can probably talk about that in terms of having a contaminated pitch. And I brewed a lot of beers with harvested yeast. I've just never wanted to deal with acid washing or rinsing it. And it doesn't seem to be necessary. And the argument is, at least with rinsing with water, is that then you don't have a good solution for the yeast to hang out in. And maybe you could talk a little bit about the science there as to why water isn't an ideal medium for yeast to be stored in.
Yeah, I mean, I don't know for sure, but it's certainly what pops into my mind is like anything, right? It's going to trigger a natural response. Water is not going to trigger the hibernation response that would happen in a sugar solution, right? So when yeast is done, when there's no more sugar to process and turn into energy, it's going to do some cleaning up, right? It's going to take up diacetyl and it's going to sort of clean up its surroundings, preparing itself to hibernate, to go to sleep for a while. In water, it doesn't have access to any of that. It can't take up, it doesn't have any nutrients to take up to prepare itself to go to sleep, right? It's like, think about like a bear, going on like this giant eating spree right before it's about to get cold and they're about to hibernate. Because a bear, I just learned this on the National Geographic Channel a couple of nights ago, a bear loses 40 pounds while hibernating, right? And so they have to eat all of that and pack it on, while they're awake so that they can lose it while hibernating. And a yeast doesn't necessarily lose all of that weight, but they do have to prepare themselves for hibernation. So it makes sense to me that in water, they wouldn't have the tools to do that. You've taken them out of this environment that they're happy in, and they're doing the fermentation and they're growing and they're doing all the stuff that they enjoy doing. And then you wash them and take all of the nutrients away from them, and they don't have anything. They're like, well, crap, I needed that to go to sleep. I needed that to, regulate my cells and get me ready to hibernate. And they just don't have it. So I think that's a situation that could be bad for the yeast. But this whole washing and rinsing thing, like you said, yeah, it was super popular like 10 years ago. And I think this is also one of those things that like home brewers were looking at what commercial brewers were doing, for example, in Germany, and going, oh, we should do that, right? Because the commercial brewers are doing it, we should do it. Now, washing and rinsing, if you do it properly and follow all of the steps and do it appropriately, washing and rinsing will ensure that you have pure yeast every time you pitch, right? The whole point is to prevent contamination. The whole point is to stop the yeast, stop pickup of anything that is going to result in a bad pitch later, right? So any dead cells, any cells that aren't viable, it's going to strip out cells that aren't vital because they're not going to be able to survive the acid rinse or the water because they don't have the nutrients that they need. So it does serve a purpose in that way of sort of making sure that you have viable and vital yeast. But again, most of the systems that are doing that are immediately pitching those yeast into a wort again, right? They're going to wash and rinse and then immediately pitch them. They're not washing and rinsing and then putting them stored into a refrigerator for a month. They're going sort of directly into a continuous propagation tank, at least from what I've seen in terms of the washing and rinsing. You can, of course, wash and rinse and go into a refrigerator, but like you said, it seems to me that the conditions that the yeast wants is the wort, right? And probably a low gravity-ish wort, something that doesn't have a whole lot of sugars in it, but has enough nutrients that when they're ready to wake up, they have access to nutrients, and when they're ready to go to sleep, they have access to nutrients. So I would think those things are important. And also, Sue, you said you went into a jar, right? And I think that's really easy to do. Jars are very accessible and they're out there. But I do have a question for you. Are you sterilizing that jar, or are you just sort of rinsing it with like Star San and then calling it good?
So I will soak a jar. Let's say I brewed a beer. I did brew a beer today, and I've used the jar that was storing the yeast. Let's say I actually didn't in this case, but let's say I did have a jar from the fridge. I pulled it out, I pitched it all in, and then now I've got this dirty jar, right? And then when this fermentation is over, I want to put that yeast back in that jar. I'm going to clean it in between. So I will rinse it with water and then do a PBW soak, and then I will rinse that again, and then I will just once it's time to put the yeast back in the jar, my preferred cleaner is SanaClean, and call it good. So I'm not using any sort of like crazy sterilization technique. Like I guess maybe you could use like a canning, like a pressure cooker or something like that. I'm not going that far.
Yeah, exactly. The pressure cooker, or, baking in the oven, baking the jars at low temperature in the oven for a long time, or baking any of the equipment, right? Like whatever is going to touch your yeast. If you're working in a lab, or if you're working in a commercial brewery and you're harvesting or storing yeast this way, they're going to talk a lot about sterility, especially if you're harvesting yeast to put it into storage, where you're not going to use it for, a few weeks or a few months or something. If you're harvesting it and putting it into storage, aseptic technique is the thing that microbiologists always love to talk about. Aseptic technique means essentially there's nothing that touches that yeast except that yeast, and or the nutrients that you're trying to provide for that yeast. But like the air around it, I mean, they use a flame that creates a draft that literally like purifies the air around the loop that you use to touch the yeast when propagating it. So all of this aseptic technique, if you're working at a brewery and you're really serious about making sure that you only want that one strain, you got to go that far. But I love that, Jordan. And this is why we're home brewers, right? And this is what's really cool about being a home brewer, and really even a lot of brewers too, right? The sterility doesn't matter as much as this if it's just sanitary, especially if you're going to reuse it in a couple weeks or a couple months. You don't need to go all the way and sterilize all your equipment. But if it does make you feel better, go for it. That's what I always say.
Yeah, I mean, I think I'm living proof that you really can make world-class beer with this method. I'm not being haphazard, right? I'm not like using old, cookie jars with crumbs in them and stuff. This stuff, PBW and SanaClean should be sufficient. That being said, maybe this is a good time to talk about the one time it did burn me. So, I mean, I've done this hundreds of times, and I brewed a Kolsch, I believe, and then I reused that yeast to brew an alt beer. And, these beers were lagered a little while and cool, fermented, maybe 6 degrees Fahrenheit. So it wasn't like a Kvik beer where I was drinking it 3 days after brew day or anything like that. And the alt beer is like, let's say, lagering at this point, and the Kolsch is now ready to drink, and I take a sip. Oh, it's like infected. And I was like, oh no, the alt beer used the same strain. And sure enough, the alt beer had the same weird thing. I think that I was able to kind of pawn them off on like non-homebrewer friends that didn't know any better. And it was like, it wasn't like totally a putrid mess, but I mean, it was not competition worthy beer. And I can't remember what the off flavor was, but somehow I picked up an infection. And was it during the brew day or during the fermentation, or was it during storage? Who knows? But, hundreds of batches in, there was only one time and it was the same pitch. Unfortunately, I caught it too late and I had 2 bad beers.
Oh, no, that sucks. I've heard stories about that. And again, that's why it's important, right? You want to make sure that you're sanitizing everything, and who knows, right? I mean, it could be just as simple as like you set the lid down on the counter, right? And then screwed it on there and something fell in. I mean, that can happen. Like you can do that. Again, aseptic technique is the best practice if you want to maintain purity, but that's great. It's still amazing that it was only one time that you got burned, right? Out of all those times, only once. All right, one other thing I wanted to ask too is, you mentioned sort of like getting it from the bottom. You can also scoop it off the top during krausen, right? If you've got a keg fermenter a keg fermenter, you can still do it, or really like an open top like stainless steel fermenter, one of the ones with the big wide opening. At high krausen, you can crack that thing open and just run a jar across a sanitized, sterilized jar across that krausen and pick up a little bit of wort that's in there. Now, don't seal that jar immediately because it is still fermenting, right? Just leave it kind of cracked open just a little bit, but set it in your refrigerator. Once that fermentation stops, go back into your refrigerator and seal the jar all the way tight. But that's a good way of harvesting yeast that's ready and viable, especially if you're harvesting ale yeast. Now, if you're harvesting lager yeast, maybe you want to get it from the bottom, but that's another easy way to do it. And another way to think about this is all those, if you've heard of Yorkshire squares that they used back in the older brewing days in Yorkshire, England, right? It's a square and it has a little notch cut out of the side of the square, and as the beer fermentation reaches that notch, the yeast spills over the bottom and either goes into a collection vessel or gets transferred over to another beer where it then starts to ferment, right? And that's the way that they harvest and repitched yeast. So there are other ways that you can do it, skimming off of the top, and I think that's even what Ritteman did in this study, is they were skimming off the top of the fermenter, not pulling from the bottom, because they were looking at early fermentation, during fermentation, and at the end of fermentation. So they can't just pull from the bottom. They have to kind of pull from where active fermentation's occurring. So they pulled that from the top. But interesting, interesting way to harvest your yeast. Now, the question that I wanted to ask you is, what do you do in beers that are dry hopped?
So my method is, if I was to do a active fermentation dry hop of some kind, I would not be repitching that yeast. I guess in theory, in some systems, you could dump the cone and then have like some of the yeast, even though there's still some in suspension, do your mid fermentation dry hop, and then that's just trash at that point, and you already have collected your good, viable, creamy pitch. But I don't really do any mid fermentation like T90 dry hops, but I do dip hops with Incognito. I did that today, and if that's the case, I just call it a loss and we'll throw the yeast away. With the oils, I think that's a whole new world of interesting discovery that you should probably have someone on that's tested that, because how is use of Incognito and the dip hop affecting viability? Because there's like now oils in the pitch. Maybe like Kelsey at North Park would have some experience with that, because he's doing that in like all of his beers, and I would assume he's not using fresh yeast in every beer. So that would be an interesting study to do. But assuming I'm not using Incognito, I will ferment to terminal. Since I'm fermenting in kegs, I will then push the fermented beer into a dry hop keg using a closed transfer system that I had already purged, put in the dry hops, sealed, purge that a few times with just gas, and then push into that. So, and then I have the fermentation keg, which is now empty, and I can pour the yeast out of that. And then I have this second dry hop keg. In theory, I'm killing two birds with one stone here. In theory, this is a better low oxygen solution instead of opening up the port of my keg and pouring the dry hops in off the top. And then two, I have fresh yeast without hops in it. And so back in the days of like rinsing yeast being like a popular homebrew kind of like piece of advice, I think that was part of it, is that people were concerned that there were hop bits in the pitch. And that was one of the steps, was to separate pure yeast cells from non-yeast trub.
Yeah, and that's definitely how commercial brewers do it too, right? Commercial brewers are going to harvest the cone or harvest yeast from the cone before they pitch with dry hops. And yeah, you don't want to pitch those dry hops in there. One is there's still a bunch of bitter acids that are in there, and those bitter acids are still harsh on yeast. Yeast can survive and adapt to them, but they're still a harsh condition for yeast. The other thing too is you've got a potential vector for other contamination, right? You've got some things that live on hop cones that might actually spoil your beer. Although I would be interested to see more about that. I don't know that anyone's ever actually done a research study to see like what micro is actually on a hop cone that survives fermentation. That'd be pretty interesting to study. But yeah, so if you're going to dry hop, do what Jordan did, transfer to a different fermentation vessel, or find a way to harvest your yeast before you dry hop. Don't take yeast with dry hops on top of it. All right, now I'm sure the thing that everybody's been waiting for, and we delayed it probably too long, is how do you calculate how much to repitch or how much to pitch from these harvested slurries? So Jordan, why don't you take us through your method for figuring out pitch rates from harvested yeast?
So years ago, I found this Yeast article that would help you estimate this stuff based on their research, and it gives you a really good rule of thumb. And so they had this chart where it showed all these different vials of slurry, and I think that's now gone, but there is still some version of it on the website. If you Google Yeast, yeast harvesting repitching, you'll find this page. And what they said was, generally, 40 to 60% yeast solids will correlate to 1.2 billion cells per milliliter. So I made that a little easier on myself and just assumed 50% yeast solids would be 1 billion cells per milliliter. So I'm kind of just making it even numbers, right? So if you have half and half pure yeast slurry at the bottom of your jar and half wort sitting on, or beer sitting on top of that, that would be approximately 1 billion cells per milliliter. Well, just look at the bottom half and double it, right? So that means your pure slurry is worth approximately 2 billion cells per milliliter. The jars, conveniently, have milliliter markings every 100 milliliters, right? And so if I'm looking at my jar and the solution, and that's the beauty of this method, is it doesn't matter the percentage of wort to or beer to yeast slurry ratio, because you're only concerned with the pure yeast sitting at the bottom of the jar. And so then if there is 100 milliliters of pure slurry at the bottom of the jar, this rule of thumb, we just double that, and that's your billion cell count. So 100 milliliters of pure white slurry is approximately 200 billion cells. Now that's on day one. So then you go into your online yeast calculator and you can discount the viability, right? And so if it's 2 weeks old, what if it's now, I'm guessing, 90% viable? So it's 90% of 200 billion cells. And with this method, the beer sitting on top, if it's a 4-to-1 ratio, a 0.5-to-1 ratio, it doesn't matter, because I know how much cells approximately are in the jar in total. And so I can decant as much or as little of that off as I want, knowing that I'm basing my estimate on the pure slurry at the bottom. So again, it's super simple rule of thumb. For every 1 milliliter of pure white slurry, you can estimate that to be 200 billion cells. So you just take your milliliter count and double it. Boom. Yeah. That's how many billion cells you might have.
Right. So one mil of cells would be 2 billion, or 1 mil of slurry would be 2 billion cells. So that's super easy. If you're just harvesting that, if you're taking that out of the bottom of your fermenter and you let it settle, and then the yeast cells, you'll see it. It'll divide out. It's pretty easy to see, as long as you're using a clear jar. but yeah, you'll be able to see it. So whatever that volume of the slurry of the yeast is down on the bottom, that's what you're counting, and you're just measuring that based on the milliliter markings on the jar, and then double that, and that's the billion cells that you have on day one. Then you use that to plug into your yeast calculator of choice, and boom, you've got the amount of viable cells that are in that jar.
Right. And so there's some variation here, I'm sure. Like they've found that some strains...
Caveat, yeah, right.
Right. So some strains are going to die quicker or have conversely better storage capabilities. There's probably some cell mass differences in different strains. And so this is an average. So so you're going to be over pitching on some and under pitching on others because mass isn't a perfect correlation, but based on their decades of research at Yeast, they're like, this is on their pro brewer webpage, right? Like, generally speaking, this will get you in the ballpark. And so, you notice that I shaved off, it's actually 1.2 billion cells, and I just made it 1. And then since we're just looking at the sorter, we double that and it's 2. So maybe I'm kind of technically over pitching a little bit, and it served me well. And so I like to lean a little high in that regard. And then, so you can kind of discount that the other direction if you maybe want to underpitch a Saison or like a Hefeweizen or something like that.
Yeah, I was going to say that's probably a good way to lean, right? Because you don't know how much of those cells are vital, right? How much of those cells are actually going to be ready to produce and make beer. So that's a good way to run it. That makes it really easy. And of course, if you want uber accuracy, you're going to have to get a microscope. And again, you can do this, right? If you've got access to a microscope or want access to a microscope, pick one up, pick up the yeast counting plates and then some methylene blue dye and follow the method, and you can do this. You can count the number of cells that are actually in your slurry. And of course, that's the most accurate way to do it if you have access to that equipment. Then you know immediately, okay, this is the exact number of cells I have in my slurry because I just take the volume of the liquid and the count of the cells, and boom, I have this number of cells per this volume of liquid. That's what we need to know, right? It's very simple. That gives you the amount, and then you can use that to calculate if you need to do a starter or if you can pitch exactly what you've got. You can go from there. The only other thing or piece of advice I'll give is that I've always heard if you say only have a small volume of yeast cells, like if you were only able to harvest a little bit for whatever reason, you harvested a lot and you knocked the jar over and now the yeast cells are, you're not sure how much is still there. If you're only able to harvest a little bit and you need to prop it up, especially if you need to prop it up more than once to get to your desired pitch volume, then do it slowly. And sort of the rule of thumb is 10 times your last volume. So if you have 20 milliliters of yeast, pitch it to, or prop it up to 200 milliliters and then to 2 liters. And this also applies if you're trying to bring back yeast from frozen. So if you're bringing back yeast from frozen, you don't want to freeze 2 liters of yeast. That would just be kind of silly, right? You only need to freeze a small amount, but you'd probably have something like 1 mil or 2 mils or 5 mils. And if that's the case, again, you want to prep it up slowly. You don't want to throw that frozen 5 mil set of yeast into 5 liters of wort. You're going to shock that yeast and probably kill it. You need to bring it up slowly so that it will actually stay viable. But using Jordan's method and harvesting, I think is totally appropriate.
Right, and that's why I don't freeze yeast, because who wants to step something up 5 times to make a beer? Now, obviously, if you had the rarest yeast strain from this 1800s brewery and yada yada yada, okay, maybe that's justified. But like people that are freezing Chico, come on, just buy another $12 pack. This is getting out of hand, guys.
That's totally true. But like you said, like this rustic, when rustic starts to if you don't know if rustic's ever going to come back from Imperial, when you start getting low on it, you may want to freeze some of it. That way you've got it. But totally, right? And the other thing that I'll leave with is I know Jordan is a big fan of pitch rate, but there's also a question of how much pitch rate really matters. I mean, of course, you don't want to you need enough yeast to complete fermentation, and enough is a loaded word, right? I mean, what is enough? And then you get into discussions of, is that, a half, 50 million cells per milliliter per degree Plato, right? Or is it 1 million cells per 100 million cells per mil per degree Plato and all this sort of stuff. What is the exact pitch rate? But a lot of people will just pitch what they've got, right? They might put it in the yeast calculator and say, yeah, okay, I want to pitch 200 billion, but I've got 100 billion, or my yeast calculator says I have 75 billion. Pitch it in and see what happens. Or you can always do that. Short and shoddy always applies. And you know, results may vary, but you can always just pitch what you've got in there and not worry about a starter and not worry about pitch rates.
Yeah, I will say, as a rule of thumb, a healthy fermentation with the proper pitch rate to begin with, you know, assuming everything is good on the first generation of the beer or the yeast strain, you can probably just repitch all of it. And that's probably about right, because it's really difficult to get all of the yeast out of the fermenter, right? Because you're not using your hand to scoop it up off the walls or whatever, right? You don't want to infect the yeast pitch. So effectively, you know, it's really hard to get it all out. Maybe in a traditional plastic carboy, like with the neck and stuff, you could maybe pour enough wort or enough remnant beer in to get most of it out. But in like the kegging situation, you just can't get it all out. So in a world where a lot is stuck to the side of your fermenter, you got about half of it, and that's probably about right. But if you could successfully get all of it out, it's probably enough for 2 brews.
Yeah. Mm-hmm. Yeah, and think about that, right? You might be able to split it out into 2 brews. And then, of course, Jordan, the last question I wanted to ask before we close everything out is, how many times do you repitch this yeast? How many generations are you going to before you throw it out? Are you getting all the way to 14 or 15 like Ritteman was getting?
I'm not. I'll just go 4 or 5 before it's time to call it quits. I've heard that Hefeweizen strains actually are not great for repitching, so I thought that was interesting. That was the case study of that last episode. And then something like Saison, where, you know, it's not the cleanest beer in the world, I'm a little more lenient in how far I'm willing to take that. But lager yeast, pure, like clean ale yeast, 4 or 5 times, it's time to go back to the homebrew store and get a new pouch. Only got burned once, like we talked about, but not wanting to risk going too far. So maybe just a couple other little tips and tricks I wanted to talk about here, and they kind of harken back to some older homebrew lore. There were a couple things that you would hear when it comes to repitching. 1 was you don't repitch hoppy beers. 2 was you don't repitch sour beers, kettle sours. 3, you don't repitch from strong beers. And 4, you don't repitch from dark beers into pale beers. And I will say I have found that pretty much all of that doesn't matter. So let's see if I can go in the order that I just mentioned it. I repitch hoppy beers all the time. Now, like we said, keep your dry hops and your yeast separate and stuff like that. We're assuming that's the case. But like a West Coast IPA with 70 IBUs can make, and I'm using lager yeast in these now, right? I can make a lager after that, and it doesn't, like a delicate Helles doesn't all of a sudden taste like, you know, an IPA, right? So when I pitch, I'm trying to get rid of most of the remnant beer off the pitch, and I'll use the wort from the brew day to swirl it up and get it into the thing. So if I'm pitching from a Czech dark lager into a, you know, Czech pale lager, the little bit of the stuff that's in there, you know, it's not going to add enough color to really make an impact, because I'm ditching the beer that's on top of it and using new wort to loosen up the slurry to get it into my fermenter, right? Now, that being said, when it comes to strength, I think that there are some considerations there. I repitch IPAs all day, and these are 1070, 1065 OGs sometime. And I'm not having problems, but I'm only going 4 or 5 generations, right? I would not repitch a beer that was like 30 Plato, you know, like if you had a crazy high imperial stout or a barley wine, that's not the time to repitch. And just to see if I could do it, I repitched a Berliner Weisse that I had used Imperial Dieter into a Kolsch, and I made a great Kolsch. And I posted on Milk the Funk, and everyone's like, what? I can't believe you got away with that. They told us we can't do that. And so not a best practice for a brewery, wouldn't recommend it. And it was just an experiment to see if I could, and it made a great Kolsch. So it is possible to repitch sour fermented beer. The concern is that the acidic environment of the kettle sour is just too harsh. It stresses the yeast out too much, and it can't make a good beer afterwards. Turns out it is possible, but you know, that's definitely one to be careful on. The only other thing I want to mention on this is as the industry is starting to mess around more with fermenting ales with lager yeast, there is some discussion as to whether we can go back and forth between cold fermentations with lager yeast to warm fermentations with lager yeast, making quote unquote ales, and back and forth. And this is a recent podcast that I heard this on, and I don't remember if it was with you or not, but they were talking about that, and they said the recommendation would be to, it's okay to go from cold to warm, but not the other direction. Now I'm matching pitch rate as well when using lager yeast. So if I'm fermenting at 60 degrees Fahrenheit, I'm pitching it at like a hybrid recommended pitch rate of like 1.0 million cells per degree, Plato per whatever, when standard ale is like 0.75 and standard lager is 1.5. So granted, I'm minding my pitch rates, but I'm going back and forth between temperatures. So fermenting an IPA right now, and then after this, maybe I'll ferment a lager with it. Not having any problems at the homebrew scale, but that's another thing that maybe pro brewers would be a little more careful with in terms of switching from cold fermentations to warmer fermentations with a lager yeast strain. You might start to see genetic drift or something down the line.
All of those sound like amazing questions for me to ask my Trey Dunham, right? Like, how do these things affect re-fermentation? I mean, or re-pitching of yeast? I don't know that she knows the answers to all of those, but it would certainly be an interesting question, because I'm sitting here thinking like, okay, yeah, in a high strength beer, right? There's going to be different stresses and maybe some interesting genetic drift, some different, genetic pressures on that yeast. If you're switching from warm fermentation to lager and then back and forth, there may be also some genetic pressure. So yeah, I mean, that sounds pretty interesting. I wonder what the genetic drift of those types of stresses would be, and if those myths are actually true or not.
Yeah, and so I think there are some cases where you wouldn't want to repitch, like we said, a super high OG. So maybe anything higher than 1080, don't repitch that. Or if you were to repitch it, maybe into another high, I don't know, maybe just don't do it. But the other thing, and we've done experiments on this, is repitching from smoked beers. I'm just thinking of this at the last second here, is I did a short and shoddy smoke, the Pivo Grozickia, which is not sour, by the way. I got to correct you. On the last episode, you said that was a sour beer.
I did. Yeah, I did.
You're confusing that with the Lichten. What was that one called?
Oh, yeah, the Lichtenhainer or whatever.
Yeah, something like that, which is a smoked sour beer. But the Pivo Grozickia from, was it Poland?
Yeah.
I made a short and shoddy one using smoked malt, the Beechwood smoked malt. And I took the yeast cake and fermented a Helles that was pure Weirmann standard Pilsner malt, no smoked malt. And the subsequent beer did have a wisp of smoke in it, which is apparently how they make that in Bamberg. The smoked Helles just uses the pitch from the smoked Märzen, which had smoked malt in it. So if you make a smoked beer, know that yeast pitch is smoke tainted, and the subsequent beer, at least a light beer like a Helles, you're going to get some carry through.
Yeah, that Sri Lanka Märzen, I actually just learned that too, right? The Sri Lanka Märzen actually uses smoked malts, but then to make their Helles, they just take the yeast pitch from the Märzen and put that into the Helles, and that gives it just the unique amount of smoke character. So that's really interesting too. Yeah, so be careful if you're making a Rauch beer or smoking, a smoked beer. Be careful about repitching that yeast. But again, all of this sort of raises interesting questions about like what could happen to the yeast as you're repitching it. What sorts of stresses are happening to it? How do you maintain and harvest it and keep yeast management? So this was a really fun episode to talk to Rittiman about. It's an episode that I'm excited to talk to my Trey Dunham about. And of course, Jordan, it's fun to talk to you about it too. Your experience in yeast management. Anything else that you wanted to add that we didn't get to today?
It's really not that intimidating. I know it might sound like it, but it's not that hard. And anyone that can make beer can harvest and repitch yeast. Highly recommend it. It's more sustainable, like we talked about in our last episode together. And the pro brewers claim that your beers will really start to hit their stride on the third or so generation. So maybe you'll be even making better beer if you're repitching yeast.
Yeah, well, with that, Jordan and I will be back in 2 weeks with our next Applying the Science episode. We'll see y'all then. The Brew Lab is a production of Brülosophy, where they who drink beer think beer. Don't forget to visit Brülosophy.com to read about our weekly experiments and other brewing adventures, and listen to us talk about it on our other show, the Brülosophy Podcast. Thanks to all of our sponsors and patrons that help make this show possible. If you'd like to receive a reward for helping us do what we do, visit patreon.com/Brülosophy to see how you can do just that. Thanks so much for listening. We'll be back in the Brew Lab with another guest next week. Until then, think beer.